Hello everyone. Thanks for joining us for today's webinar, Near-Infrared Spectroscopy in Personal Care Industry, the ideal tool for quality control and product screening. My name is Maria Cartes, and together with me are my colleague Andrea Sagerer, who is going to hold part of this webinar, and Wim Gams, who will help us in the question and answer session. We are part of the Competence Center Spectroscopie in Mettre International Headquarters in Herisau, Switzerland. Before we dive into today's topic, I would like to go over a few housekeeping items. If you experience any audio issues or if your screen freezes, try refreshing your web browser, which will usually fix this issue. If you have any questions during the webinar, please type them in the Q&A box at the bottom of the screen. Any question that we cannot answer in the Q&A session after the webinar will be answered by email. So let's have a look on the agenda for today. The webinar is structured as follows. I will start giving you some introduction about the personal care and cosmetic industry, following for an explanation how near-infrared spectroscopy works. Later, my colleague Andreas will present you some applications and conclusions. As mentioned before, we will have the question and answer session afterwards. Well, personal care and cosmetic products are widespread in our daily lives. From the moment we wake up in the morning, we all participate in ancient rituals. Most of us wouldn't really go out or go to the bed without first practicing a bit of hygiene, which is why these products are so widely used. Personal care products and cosmetics are mainly applied externally, for example, on skin, hair, and nails, as well as orally, like for example, on teeth, lips, and tongue, either for hygienic purposes, to modify appearance, or for general body maintenance. Personal care products are usually rinsed off immediately after use, with some exceptions like hand sanitizer or sunscreen lotion. Some of the many examples of these items used on regular basis include shampoos, soaps, toothpaste, mouth rings, shower gels. For other hands, cosmetic products are living on the skin for a few hours, like skin creams, perfumes, makeup, or also insect repellents. Other products used for hygienic practice are laundry and dishwashers, like laundry detergent, soap capsules, dishwasher tablets. The quality control trends in the regulated industry. Well, considering the prevalence of these kind of items in our everyday life, the amount of time they spend in our skin, the largest organ of the body, and the effect can have on the environment after use, proper quality control of personal care and cosmetic products is extremely important. In general, regulation for personal care and cosmetic products are not as strict as those for pharmaceuticals, but there are certain similar trends. Aside from safeguarding our health, it is equally important to avoid the sale of out of specification products. Product recalls are very expensive and have a lasting effect on a company's reputation. Therefore, intensive testing of these different care products is essential before they are brought to the market. Near-infrared spectroscopy is a technique that is quite suitable in such regulated markets. Further drivers for implementing stricter and more frequent testing are the following. As mentioned right now, cost pressure. Frequent testing can reveal costly out of specification products, allowing production to be adjusted or stopped in plenty of time. Increases competition. Quality practice provides a competitive edge and can be used as a marketing tool to raise brand values. Scarcity of resource. Qualified staff are difficult to find. Therefore, checks that can be carried out by non-specialists are invaluable. So why? Why people turn to NIR spectroscopy? As mentioned before, near-infrared spectroscopy is an analytical method that is particularly suited for making quality control of these end products more efficient and cost-effective, replacing analytical techniques which are slow, costly, and or time-consuming. With near-infrared spectroscopy, it's possible to analyze multiple parameters at once, and it's possible to determine physical and chemical properties of a material. But how does NIR spectroscopy works? So let's have a look now. NIR spectroscopy is based on the NIR light. The NIR light leads in the wavelength range of 800 to 2500 nanometers of the electromagnetic spectrum. As you can see in this slide, NIR light range is between the middle infrared and the visible region. NIR spectroscopy is based on the absorption of NIR light by various atomic bonds. This interaction can be registered in the NIR spectra of a sample. As you can see here, some spectra are shown in the visible NIR region. And thanks to reference values and chemometrics, we can use those spectra for identification of substances or for quantification of several parameters like moisture, viscosity, free fatty acid, color, because also the visible region is registered, and active ingredients, for example. So really a lot of parameters can be detected by NIR spectroscopy, can be measured with NIR spectroscopy. The interaction of this NIR light with the material generates change in the vibrational state of the molecules. This NIR region is ideal to quantify molecules with CH, OH, and NH bonds. With NIRS, with NIR spectroscopy, different samples like solid, liquids, and creams can be analyzed, and depending on the sample type, a different instrument is used. Above, you can see a picture of the DS2500 liquid analyzer, and below, you can see a picture of the DS2500 solid analyzer. In this slide, I have a video to show you how easy it is to measure solid samples with the DS2500 solid analyzer. Solid samples like granulates, pellets, flakes, past, powders. The sample is placed into the analyzer using a sample cup. And as you have seen, no sample preparation is required. The measuring mode used for solid samples is the diffuse reflection mode. In this animation, I will show you how this reflection mode works. So the NIR light penetrates into the sample and interacts with it. Part of this light is absorbed, while unabsorbed NIR light is reflected back to the detectors. With the DS2500 solid analyzer, it's also possible to measure slurry, suspension, creams, and past, as you can see in this short video. We can measure this kind of sample using a gold reflector. The gold reflector is placed behind the samples, as you can see now. And this measuring mode is called transflexion. In this video, in this animation, you can see how it works. So the NIR light is transmitted through the sample, and thanks to the reflector, is getting back to the detectors. It's a mixture between the measuring mode mentioned before, the reflection mode, and the transmission mode, that I will show you right now. The transmission mode is used for liquid samples, and the DS2500 liquid analyzer is the instrument that we use for this kind of samples. As you can see in this video, you only need to fill the liquid into the vials or cuvettes to put into the instrument, and the sample is measured. In this animation, as before, I show you how the transmission mode works. So the sample is placed between the NIR light and the source. The sample is placed between the NIR light and the detector. NIR light is transmitted through the sample, and any unabsorbed NIR light is detected by the detectors. So now you know the basics behind NIR spectroscopy, but how do you get a result from this measurement? For this, mathematical models called prediction models are created. We can differentiate basically 3 steps. As you can see in this slide, the first step is the collection of the calibration set. The second step is create the prediction model, and the third one is validate those prediction models. First step, the calibration set. It's necessary at least 20-30 samples. We register the spectra of the samples, and it's also necessary to have the reference values. If we have a look in this slide, we see as reference the moisture. So for moisture measuring, we can use Carfish titration to get the reference values. So first step, calibration set, we have the NIR spectra for one hand and the reference value in the other. Second step is to create the prediction model. So once we have the NIR spectra and the corresponding reference value, some correlations are applied using mathematical models. We select specific areas of the spectra. In this example of moisture, we select the OH region of the spectra. And thanks to those mathematical models, we can create some correlation between the NIR values and the values from the reference values, in this case, moisture. Once we have a good correlation, it should be necessary to validate our model using a second batch of samples. Validating our prediction model, we can have the standard error of prediction of our model. In this example of moisture, we got 0.03%. The standard error of prediction is always higher as the standard error of calibration. In our examples, 0.02%. So now we have already collected the calibration set. We have created our prediction model, and also we have validated those prediction model. So now we only have to run the routine analysis in order to measure the moisture content in our samples in this example. The routine analysis is really easy. You have seen already some videos how the procedure is. So the position, you only need to position the sample into the analyzer. In the Visionaire software, select the corresponding operating procedure, and after some seconds, you get the results for moisture or other parameters like intrinsic viscosity, for example. So by end of my presentation, I just want to resume the advantage of NIRS. So minimal or also no sample preparation is required, and also the sample can be reused. No solvent are used, so it's a chemical-free technique. Results are displayed in less than 1 minute, and the determination of chemicals and physical parameters is possible. No need for consumable, only the disposable vials if you don't want to clean them, of course, and can be used by untrained operators. Something important is also that NIR spectroscopy is compliant with 21 CFR Part 11 and USP regulations. So now I will hand over to my colleague Andreas, who is going to present you some application examples. Thanks, Andreas, and thanks for your attention, all of you.
Thank you, Maria, for a nice introduction. After the theory, this part of the webinar focuses on some use cases of NIR analysis in the personal care industry. Next to identification and qualification of incoming chemical or biological substances, the main near-infrared application is quantification. Listed is an overview of the most important parameters, but there are many more which can be measured with this technology. Based on the limited time of the webinar, we have selected 4 application examples with different personal care products. Application 1 is the quality control of moisturizing creams. Then we head over to quality control of shampoo, followed by the QC of hand sanitizers. The last application is the quality control of laundry detergents. The first application is the determination of moisture and other parameters in creams. During a feasibility study with a customer, the following questions came up. Is the quantification of moisture in different creams possible with NIR spectroscopy? And yes, this is possible. Since water is a strong IR absorber, this application works well. I will show you the results in the upcoming slides. Next to this parameter, the customer was also interested in the sun protection factor. Often inorganic oxides are used as a protective additive, for example, titanium dioxide. Since those compounds reflect NIR light, they can be measured in creams using NIR spectroscopy. In general, active ingredients can be measured with NIR, but the type of ingredient needs to be known. Changes in the spectra can be observed with different additives, but it is difficult to exactly link those changes in the spectra to one specific additive. Now let's come back to the determination of water in creams. How were the 42 commercial samples measured? First, the cream was filled in a special accessory called the slurry cup. You can see the accessory here. As you can see, it has edges at a certain angle, which makes the cleaning process after the measurement much easier. Second, a gold deflector was put on the sample. This guarantees a stable measurement setup. With it, the path length is constant. It removes air bubbles and sample signal is increased. After the spectra were acquired on a DS2500 solvent analyzer, the moisture content was determined with Kalfischer titration, dissolving the samples in methanol and then titrated with Kalfischer reagent. These Kalfischer values were then correlated with NIR spectra to create a calibration model. This calibration model is displayed here, where on the x-axis the values from the titration method is displayed, and the y-axis the values from the NIR determination are displayed. The blue dots are the samples used for calibration, whereas the light blue dots represent samples that are used for validation only, so they're not contained in the calibration model. In a perfect correlation, all the dots would align perfectly on a 45-degree angle. So as you can see, there's some deviation there between both methods. What you get is an R-square value that is very high of 0.99. That displays a high correlation between both methods. A standard error of calibration that displays just the model robustness here. A standard error of cross-validation that is used to validate the model. So one sample is removed and then used for validation. That is done for every sample. But to really measure the robustness of the model, here a standard set was used that is not included in the calibration model, and this is then used for prediction. Therefore, you get a standard error of prediction that is shown here. Another application is the active ingredient in shampoo. The objective was to quantify the main 5 components in its product. So sodium lauryl sulfate, CABP, CAV, and DEA, next to carbopol. Below, there different sample measurements with different concentrations were obtained from the producer and shown here. The results show a low standard error of only 0.14% for sodium lauryl sulfate. You can see here next to the correlation diagram. All 5 ingredients could be quantified and robust models were obtained. Below, different figures of merit for all the parameters are displayed, together with the range of all 5 parameters. Overall, it shows that NIR is a good method for quantification of all 5 active ingredients in shampoo. Next to that, the cost and time saving compared to the standard HPLC method is huge. And I want to show you that in the next slide. To compare the standard HPLC method with the NIR method, an average of 10 samples per day and operator cost of $25 per hour was assumed. The time spent for each sample, mainly here, sample preparation was 5 minutes on HPLC, but only 1 minute overall on the NIR analysis. Overall, with consumables, this leads to a total running cost per year of $18,000 on HPLC, whereas with the NIR, only $2,000 were needed. On the right-hand side, the running cost over 3 years is displayed, which leads to a running cost of around $50,000 with the HPLC and only a few dollars with the NIR method. Let's talk about the application of ingredients in hand sanitizers. During the Corona pandemic, hand sanitizers were products that were produced in large quantities and therefore were important products to be checked in quality labs. We were in contact with different producers and conducted feasibility studies on gel and liquid type hand sanitizers. In this webinar, I want to show the objective and result of the liquid type hand sanitizers. 3 main ingredients were of interest. First, the ethanol content need to be higher than 60% so that the sanitizer is antiseptic. This is needed and also shown by the WHO organization. Next to that, the hydrogen peroxide content, but also the water content was of interest. Hydrogen peroxide content was determined with permanganate titration, and the water content was measured using Carl-Fisher method. In total, 91 different samples were measured in transmission mode using the NIR. All samples were conveniently measured with 8 mm disposable glass vials. After the measurement, no cleaning is necessary. The vials can be simply thrown away. Although some saturation is present at the higher wavelength areas of the spectra, the model development was successful. NIR is well suited as a reliable and quick method if the ethanol content is over 60%. Next to the ethanol content, also for the other 2 parameters, the correlation with the standard method is high, which results in robust calibration models. The last use case is the analysis of laundry detergents using near-infrared analysis. Surfactant content is the most important parameter since it is responsible for the cleaning effect. In the study, 37 different samples were measured in transmission mode using 1 mm quartz cuvettes and a DS2500 liquid analyzer. The reference data was received from potentiometric titration. The content of surfactant spans from around 2 millimole per 100 gram sample to around 48 millimole per gram sample. The figures of merit illustrate the robustness of the model with a high correlation and close ratio between the standard error of calibration and the standard error of cross-validation. Overall, the NIR is a good method for quantification of surfactants in laundry detergents. Using NIR for this application saves around 10 minutes per sample compared to the titration method. At the end of this webinar, I want to summarize all the findings in the conclusion and give you additional information on where to find the application notes. To summarize, the near-infrared analysis technique is easy to use since it does not use any solutions or sample preparation. So therefore, no expertise is needed to measure the samples. Each measurement takes only around 30 seconds to 1 minute based on the settings used. This, on the other hand, saves time and costs. Next to the time saving, also no waste is produced because the analysis is non-destructive and it's a chemical-free analysis technology. This at the end has minimal impact on health and environment. Here you can see a list of different application notes for the personal care industry. All these application notes are accessible via the Metro homepage or the link described on the left-hand side. If you need more information about different key applications, you can either write Maria or me an email to follow up. Now, at the end, we want to head over to the questions and answer section. To do this, I want to introduce to you Wim Gans, which is the moderator of this section. Thank you very much for your attention.